Okay, let me to start the lecture. Hello again and welcome to our class. If you remember in the previous lecture, we talked about how JUnit helps us to writing our test codes and run them automatically. As you know, one of the first examples of JUnit that illustrated in your class is the sorting problem, and for this problem I wrote an insertion sort method in a business class in Java programming language, such as this. This is a business code, as I told before. When we use a JUnit, we have a business class, and inside the business class we could have a test class. So we named the main class as business class, and we have written our business code in this class. Our business code in this example is an insertion sort method, and some other simple methods like find maximum and find minimum of the array, of an input array. As you see before, in the test class we could define some test methods that would be run automatically on our business class. For example, in this case, we have three test methods named insertion sort test, find max test, and find min test. As you know, before each of our test method, we should use the prefix or annotation @test. So in this class we use @test 3 times for 3 our test methods. As I told before, each of these test methods is a test case. Indeed, each of these test methods is a test case. In this case, in this example, you will see later that it's possible in some test methods to have more than one test case. But in this case, each test method just is a test case. So in this case, in this business test class, we have 3 test cases. The first test case tests the insertion sort method, and the second one tests the find max method in our business class, such as this, and the last one tests the find min class, the find min method. For example, in insertion sort test, we should provide a test input or input data or test data. So before the test method, we have declared a list of integers, an array of integer such as this, in order to use as test data. So in the test method, we call the insertion sort method of our business class for this test data. After the execution of this method, our list should be ordered, and if we compare this the result of this method, as you know, stored in list again in our variable list or array again, we can compare the list after the execution of insertion sort with our expected result. As you know, the expected result could be the same as this. This is the sorted list. This is a sorted version of our initial form of list. So for a comparison of two array, we should use a for loop to compare each pair of array elements accordingly. So we use a for loop to check if each element of the list is the same as that element of the sorted list. To checking this, we use an assertion. We use an assert equals method. As I told you, an assertions are methods that compare its two parameters to be the same. If these are be the same, and the assert equal shows the passing of our test. But if it's not the same, if they are different, it would be failed and return a fail value. So this is a review of our previous lecture about how to writing test codes, test script in JUnit, and let's go to the next concepts in JUnit. Before we go ahead, let me look at your messages. Please, we have downloaded the Java and uploaded the file to it, but there is an error in the implementation. I have sent you our implementations via the WhatsApp group. You can use my implementation. This implementation is okay. As you see, this could be run perfectly. As you can see, 3 test cases are run and there is no failure for this business. Please note that you should run or debug the business code, the test class, not the business class. The business class could be run if it includes a main method, but as you see, there is no main method in this class, so this business class could not be executed at all. Okay, we should run the test class. In the test class we have defined our test methods and the test runner of JUnit, the test runner component of JUnit can detect the test methods and run them properly. So at the end of this session, we will introduce you a complete course of using JUnit, which includes at least 3 hours video that teach JUnit thoroughly. And I have sent you before another video about how to use JUnit with Eclipse and how to write simple JUnit test cases in Eclipse and run it and observe the result of the test cases. We have another message. We must install the program to run the test. Okay. There is a problem with the installation. I have introduced to some of your friends a video that train you to see how to install the Eclipse or JUnit. You should search for similar videos to learn how to install the Eclipse and how to use JUnit. I think I could not help more than these talks. Have you any problem? Have you any question? Okay. Let me to review our previous slide and then return back to our main slides. Okay. As you know, when we use the main method of each class to writing the test codes, our main methods will be very messy, and we should clear our test codes soon, because we could not keep them for a long time, and we use the main method for other purposes. So in traditional testing, as you know, we should use a main method, and there is some disadvantages, because first of all, our test codes should be discarded very soon, and it's impossible to use them in other times, and it could not be reusable tests. And in addition to this, we should keep the test code in our business classes, and the test code should be coupled with business codes, and it will be confusing. So when we use a test class separately in JUnit, we could use the advantages of this framework, such as running the tests automatically, generating the reports automatically, and in this framework there is no need to estimate the failness or passing of some tests. So we summarize these concepts as shown in this slide, and we have seen before. The drawbacks of traditional testing method is that first of all, as I said before, the test code coupled with business code, both of them in the same class. And the second disadvantage is written tests should be discarded, because our main method would be very messy and confusing. The third disadvantage is that in the traditional testing method, we could run each test at a time. Just we can run one test at a time. And another disadvantage, as you know, the programmer executes the tests himself. This means the test execution is not automatically. The programmer should check the result of each test himself to detect, to determine if the test was passed or failed. I talked about this slide before, but as you experienced to see how JUnit works, this is very more meaningful than the previous time. So we need unit test code that would be repeatable, and it would be executed automatically, and the acceptance of test should be determined automatically, which tests are passed, which are failed. So we have shown some examples to you, and let me return to our main slide, which is prepared by Professor Afut and Paul Aman. Okay. I have talked about in another session this first slides of this chapter, but as you know, you have not received my screen, and just you have sound. So I review this first slides quickly, so you have some more explanation about these concepts. The first slide talks about what is test automation. As you saw before, in JUnit, indeed, we use this software to control the execution of tests. You see this sentence practically from using JUnit. So the use of software to control the execution of tests and the comparison of actual outcomes to predicted outcome or expected outcomes, and in addition to this setting of the test preconditions and other controls such as reporting functions could be integrated in a framework, in an infrastructure that altogether automate the testing. So we have experienced this the message of this box practically by using JUnit in this session and previous session. So we define the test automation as the use of software to control the execution of tests, the comparison of actual outcomes to predicted outcomes, and the setting up of test precondition. We will illustrate and explain more about this part of the definition in next example. And other test controls and test reporting function, as you saw in using JUnit. What's the advantages of these frameworks or of this automation? It reduces the costs. Our costs would be reduced by using this framework or these frameworks, and reduce human errors. The testing, the traditional testing especially, could be very error prone, and using of the automation frameworks could reduce human error. And as I said before, reduce variance in test quality from different individuals, significantly reduce the cost of regression testing. In regression testing, we should just execute tests related or connected to the changed parts of the software. Not all of tests are repeated in regression testing. So this framework could be very helpful in regression testing. We have a message. Do you hear me? Do you have sound? Please tell me, do you have my sound? Okay. Miss Hannah, probably your connection has problem. Okay. But what about testability? The testability is defined in this slide as the degree to which a system or component facilitates the establishment of test criteria and the performance of tests to determine whether those criteria have been met. The simpler or simplest definition of testability is that how hard it is to find faults in a typical software. How hard it is to find faults in the software. As I defined before, to find faults we have to use some test criteria, such as those you have experienced in chapter 2, such as edge coverage, such as pass coverage, such as edge pair coverage in control flow graphs. So to find faults by testing, we have to choose then some test criteria, and we have to detect or extract our test requirements, and we have to provide some test data or test values to cover all of the extracted requirements. So how hard it is to do these tasks could be overly defined the testability. So the testability is defined the degree to which a system or component facilitate the establishment of test criteria or coverage criteria, and the performance of test, how the performance of a test could be measured. Can you tell me the performance of tests could be measured mathematically? How it could be done? How we can evaluate the performance of a test set? Could you tell me? I've talked about this concept before in chapter 2. Please note that the performance of our test set could be measured by how much of our test requirements could be covered by a test set. The percentage of our test requirements that would be covered by the test set is an estimation of the performance of the test. So we use test coverage criteria to determine, to extract the test requirements, and we use some execution passes or test passes to cover these requirements, but it's possible to not cover some of the requirements. All of our test requirements necessarily could not be covered. So we could cover a portion of our test requirements. The percentage of the test requirements that could be covered by a test set shows the performance of test. Okay. So we have defined the testability as the degree to which a system or component facilitate the establishment of test criteria and the performance of tests to determine whether those criteria have been met or not. Okay. Indeed, how hard it is to find faults. In other words, we define testability, that how hard it is to find faults by this system, by this process, by the process of defining a test coverage criteria, extracting the test requirements, generating the test values or test cases to cover the test requirements. Okay, so the testability is dominated by two practical problems, which includes the first one is how to provide test values. How it is hard to generate test values to the software according to our test requirement. How much easy to provide test values for covering a test requirement. This could be essential problem in generating test data. So if we could provide test values easily, we say that our software is more testable. But if it's difficult to generate test value for covering some test requirements, we should say the testability of that software is very poor, very low. So the testability is dominated firstly by the efforts needed to provide test values. If it is very easy, the testability is high, but if not, it will be very low. The second problem in testability is the observation. How much easy to observe the results of a test execution. In some systems, the result of test execution, for example, saved in a very big data set or very big files or remote files, or is a feedback for another hardware system that could not be seen easily. So in that systems, we could not observe the results of test execution easily. It would be difficult. So we called the first problem as the controllability of software, and the second one as the observability, in which the observability is about how easy to see the results of the test execution. But the controllability address that how much effort needed to control the software, the behavior of the software. As you know, we can control the behavior of software by its inputs. By the input, we can control the software behavior. But when we want to do some specific behavior, we should provide a proper input values. How it is easy to provide these proper input values? This is an estimation of the controllability. So let me to define formally the controllability and observability according to this next slide. We define formally observability as how easy it is to observe the behavior of program in terms of its outputs, effects on the environment, and other hardware and software components. This definition is very clear, and there is no need to talk more about this definition. And this sentence says that software that affects hardware devices, databases, or remote files have low observability because it's difficult to see the result of any test execution. Okay. On the other hand, the controllability is that how easy it is to provide a program with the needed input in terms of values, operations, and behaviors. For doing specific behavior by the software, we should provide a proper input values. How easy it is to provide that input values. Easy to control software with inputs from keyboard. How easy, how much easy to control software with input values, or inputs from hardware, sensors, or distributed software. As you know, in data abstraction, we ignore some details of our entities, our software entities, so the abstraction could reduce the controllability and observability. Unfortunately, in our approach, means model-driven test design, we use a data abstraction to generate our test cases. So data abstraction reduces the controllability and observability. Let me see your messages. My voice is not clear. Excuse me. Excuse me, I check my connection again. My net is okay. Which one of you can hear clearly? Which one of you can have my sound clearly? Yes, I have recorded this session. No problem at this point of view, but it may be not clear in our recording. Let me change my position, my phone position. Excuse me. I return back soon. Excuse me, what about my sound at this time? Do you hear clearly? Do you have my sound? Please tell me. Yes. Okay. Excuse me. Let's go. What about the components of a test case? As I defined before, a test case is a multi-part artifact. We define it a structure which includes the test case values, the expected results, the prefix and the postfix values. So we define a test case by four components. It includes the test case values, expected results. You know enough about expected results and test case values, but a bit about the prefix and postfix. We will explain enough about prefix and postfix soon. But let me to define formally the test case value. As you see, the test case values is the input values needed to complete an execution of the software under test. Okay. The test case values is test data is our input values. For example, values of our input parameters of the method under test, as you see in insertion sort. In the insertion sort, you saw that this is a test case value, because this list is passed to the insertion sort method as a parameter and its input data. But the other component of our test case is the expected result. The expected result in our insertion sort is this. In other methods like find max test, again the test case value is our array, our input array, the list array. But the expected result for the method of find max is the maximum value of this list. As you know, the 7 is the maximum value of the array. So we set the expected max to be 7. And in our assert equal, we compare the expected max with actual max. The actual max is the result of the execution of find max over this array. Okay. So you know the test case and expected test case values and expected results from a JUnit example, but the formal definition of the expected result is that the result that will be produced by the test if the software behaves as expected. The test worker is a component of our testing framework, which compares the expected result with test result to evaluate test execution to show the tests have been failed or passed. Okay, so the a test oracle uses expected results to decide whether a test passed or failed. But what about the prefix values and postfix values? The prefix values is the values that is needed to put the program in a proper state to run the test, to execute any of our test cases. So we define formally prefix values as inputs necessary to put the software into appropriate state to receive test case values. We talk more about this definition soon via the JUnit examples. And postfix values are any inputs that needed to be sent to the software after the test case values are set. Please note that we should put the program in a proper state after execution of each test method, because the execution of test methods change the state of our program, and after execution of each test method we should put the program in such a state that we previews the execution of our test case, with the software be in that state just before the execution of the test method. So for the first definition, we also use verification values, which is values needed to see the result of the test case values, and the postfix values, also called exit values, because before the exit of any program we should put the program in a proper state, which be just before the execution of our test method. We will see some examples about prefix values and postfix values, so don't worry about these concepts. So we have a comprehensive definition about test case in this slide. The test case is defined as the test case values, the prefix values, postfix values, and the expected results necessary for a complete execution, which executions are complete. The executions of a software which led to a final state of a software is a complete execution. As you have seen in previous chapters, we could define execution passes by the control flow graph. So any executions of a program that leads to a final state of control flow graph could be a complete execution. So a test, as I said before, a test case has 4 parts. test case values, prefix values, postfix values, and expected results, which is necessary to complete execution and evaluation of the software under tests. Some of these postfix values, prefix values are needed to evaluation of software behavior. But a test set is a set of test cases. In our JUnit example, in this JUnit example, this test class is a test set because it consists 3 test cases. Each of these test methods is a test case. So we have 3 test cases in this test set. So a test class could be a test set. Ms. Hannah, please say your message. You requested a mic. Okay. But what is an executable test script? Clearly, actually, this code, this test class, is an executable test script. So we have experience to work with a test script, to generate a test script with 3 test methods. So an executable test script is a test case that is prepared in a form to be executed automatically on the test software and produce a report. So this is a test case as you see in our example. Okay. So we summarize our talking with this definition about test automation framework. A test automation framework is a set of assumptions, concepts, and tools that support test automation. So we could say that JUnit is an test automation framework because the JUnit provide an infrastructure to write our test scripts and execute them automatically and generate a reporting which consists of how many tests are failed, how many are passed, and what tests are failed and what are passed. So the JUnit framework is a automation test framework. In the next 3 or 4 slides, some features of JUnit are discussed as we take a quick overview of these slides and go to the next examples. As you see that JUnit is an open source Java testing framework used to write and run repeatable automated tests. And it is a structure for writing test drivers, as you experienced in this session and the previous session. The JUnit features include some assertions. The assertions is a main part of the JUnit framework, because these assertions evaluate the result of our test cases. We have some assert methods, such as assert equals, as you saw, such as assert true, assert false, assert null, assert fail, and so on. And we will see a list of these assertions in next slide. Test features for sharing common test data. As you experienced in this example, we share this test data for all of our test cases. We have 3 test cases, which all of them uses this test data in common. Okay. The test suites for easily organizing and running tests. You have seen that we use a test class to define a test suite, and it could be included with some test methods. And JUnit can use a graphical and a textual test runner to show the test results, as you saw just a moment before. JUnit is widely used in industry. JUnit can be used as a standalone Java program, or could be integrated within an IDE, such as Eclipse, such as IntelliJ IDE, or such as NetBeans IDE. JUnit could be added as an add-in as a library to all of these mentioned IDEs. JUnit can be used to test an entire object with all of its methods. A part of an object, as you see, we write a test case that just tests an insertion sort. Our test class could be included just by insertion sort test method. So you could test just a method of an object, or you can test an interaction between several objects in JUnit. When a JUnit test case uses 2 instances of 2 different classes, and it calls some methods of them which interact with each other. You could test the interaction between those classes or those objects. It's primarily intended for unit and integration testing, and it could not be used as system testing. It's just for unit test and integration test. Each test is embedded into one test method. You see these concepts, and there is no new subject in this slide to tell you. And you have seen how to writing tests for JUnit framework, and it's not necessary to talk about this slide. As you saw, we have used assertions in our test methods. We have defined some test methods in a test class. We have seen the reports generated by the JUnit in Eclipse IDE, and a notable thing that I talk about it and emphasize it is that all our test methods should be as a void type. The return type of all methods should be a void, not any other return types. Some of assert functions that we will talk about it in this section, in this chapter, is includes assertions such as assert true, assert equal, assert null, assert fail, or so on. So let me go ahead. A test fixtures is the same as prefix and postfixes. The prefix methods do the initialization of our test methods or our test classes, and the postfix values is reset values, which put the state of the program to the state that is just before the execution of our test. But for defining the prefix values and postfix in our test codes, we use the annotation of @ before or @ after, according to these two fixtures, prefix and postfix. The prefix should be defined by annotation, by this annotation, and the postfix is defined by the after annotation. This is our first simple program that you have seen previous session. This is a simple calculation class which includes just an addition method which receive two integer parameters and return summation of them. And for testing this method in JUnit, we should define a test class as you saw before, and we should define a test method with by the annotation of @test, and we use the assert true assertion of JUnit to compare the actual result of calling the addition method of calculus with two concrete parameters, two concrete input values, and the expected result. As you know, the expected result for the addition of 2 and 3 could be 5. So we can compare these two parameters with assert true. If this condition be true, the assert true will be passed and the test will be passed. But if this condition be false, the assert true failed, and consequently the test method failed. So these are test values, our test case values. This is our expected result, and when the expected result be different with the actual result, the assert true would be fail, and when it would be fail, this message, this string should be printed in our console to show the fail of our test cases. What time is it? We have time. I think we have enough time to explain the next example, but before it, let me see your messages. Yes, JUnit is a library for Java programming language. If you are tired, we can finish the session, and let me complete this chapter by recording, because we need some extra sessions. We didn't hold some of our sessions before. If you are tired and it's confusing for you, let me complete via recording session. Okay. Let me to introduce you a video which is a complete course for JUnit. I will explain the rest of these slides of chapter 3 via a recording lecture, and you can see a video which is full course of JUnit. This video, I will send you this link via WhatsApp group. This is a complete course. This is a full course for using JUnit and writing test scripts. I think this is a good video. You can see about using JUnit version 4 and version 5, and this is more than 3 hours. You can learn as much as possible from this video and complete our course. In addition to our next lecture about the next 2 examples explained in the later slides. If you have any question, please ask your questions. Please prepare your presentations or study project soon. I'll ask you to represent your findings about your study in class or as some of you asked me for recording, for take a record from your presentation, please note that you would be evaluated by this representation. So you should discuss about the results, the research method, about the problem and the challenge that treated in your research paper, your studied research paper. So there is need to explain your research paper thoroughly in class or in extra sessions with a little of your friends, so you can contact with me to set extra sessions for representing your research paper. As you know, in this system of education, it's hard to evaluate your abilities, your findings, and one situation that I could evaluate you is your presentation, and talk about you with more elaboration about the problem, about the solution, about the test data, the data set, or how the solution be evaluated in your research paper. This all get me some evaluation of your abilities. So you should represent in class or in extra sessions that you can set time with me in other times. Please ask your questions if you have any question. Okay. Thanks a lot for your attention in this session, and I will see you soon in next session. I will prepare a recording about the later slides of chapter 3, and I hope we complete the chapter 3 by the recording lecture as I will done. So good night and في أمان الله.